Hello and welcome back to Calculus 1. We are talking about working with integrals. In this section, we're going to learn a little bit more of those rules that we can use. Three formulas that will be covered here. Two of them for faster calculations, and you have to be very careful with those. And then the third one is the average, which shows up again in calculus 2, 3, and then later on differential equations. So let's start with a little review. So y equals f of x from precalculus. And we know that these functions can be either even or odd. So function is even when condition f of negative x equals f of x holds. So for instance, x squared plus 9 is even function, because when you plug in negative x, the square will kill the negative and you have the same function back. Function is odd when f of negative x is equal to negative f of x, like x cubed minus 3x, in which case it works with a negative. Sine is odd function, tangent is odd function. You memorize those, and you learn why in Calc 2. And you also have that cosine is even function. So now here are the two calculus formulas for definite integrals that involve these. The first one says if f of x is even, which means symmetric on the y-axis, then the integral negative a to a f of x dx is two integrals 0 to a f of x dx. Why does this work? How does this work? Well, it's exploiting the symmetry. If the function is even, it is symmetric on the y-axis. So a perfect example would be, let's say, x squared. If I need to compute x squared from negative 2 to positive 2, it's symmetric. So instead of computing negative 2 to positive 2 x squared dx, I can compute 2 times 0 to 2 x squared dx. All this does is gives us easier calculations, because in the first case I have to compute at negative 2, right, minus f of e, and over here I will be computing it at 0, which is easier calculation than at negative 2. With all the computing power today, it's not essential, right, to know something like this. But if you are to pursue mathematics later on, end up with Fourier transforms and stuff, these things will actually cut out a page of calculations. So, not a huge impact on what we do in calculus in undergrad work. It's a cool formula, but it's a dangerous formula, because you have to understand that there are two conditions for this to work. It is not just a symmetric function, which is even function, and you need to know whether a function is even or not. But also you have to have a symmetric interval. It doesn't work if it's from negative 3 to 2 or from negative 5 to 7. It has to be the same number, which is why negative a, positive a. So those little details are actually essential for the formula. So make sure that the numbers have to be the same amount of value away from 0, so symmetric, and the function has to be even. So that's the first formula. The second formula says if f of x is odd, then we have this situation. On the symmetric integral, you are getting 0. If the function is odd, it's symmetric to the origin. Symmetry to the origin is guaranteeing that you have a positive and a negative area, and they cancel to 0. Function to think of would be sine x from negative pi to positive pi, or negative pi over 2 to positive pi over 2. I'll draw from negative pi to positive pi. Integral from negative pi to positive pi, sine x dx is odd function. It's clearly 0. You have to be careful. Again, I'm stating this. You have to be careful, because if the question says find the area under the curve, absolute value here, and you will have 4. But if it says just what's the integral, then it's fundamental theorem calculus, the answer is 0. So this question has 2 different answers depending on which question is posed. Again, like for the even up there, symmetric interval is important, and the function needs to be odd. So these numbers have to be the same with the minus sign. So those are the 2 formulas. Again, they're there for faster calculations. And the one formula that actually you need to know now, the third one, is the average value function. So to compute the average value of the function, it is f the bar, is going to be 1 over b minus a integral a to b f of x dx. Conceptually, this should make sense. If all of your exams, let's say you have 5 exams, and they're all equally weighted, how do you find the average? You add all the grades and you divide by 5. So this is that 5, right? And then you know that integral is that summation symbol, right? So here's your addition of all of it divided by the how many you have. What is this actually computing? It's computing the average value of the function. So when you have something like that, the average value of the function, let's say, nope. I'm trying to make these 2 areas the same. So this is your f of x, and this is your f bar. So let's compute an example. I'll do one, you do one, and we're done. Yeah. We're staying 3 minutes extra. We have donuts now. Oh, yeah. 25. Function is f of x equals 1 over x. And we would like to find the average on the interval 1 to e. So what's the average? Well, obviously we just plug everything in the formula and compute. But conceptually, 1 over x, right there, this is 1, and this is e. We are looking for a value somewhere in there that will give me the areas to be the same. So average value is 1 over e minus 1 times the integral 1 to e 1 over x dx, which is 1 over e minus 1. What is the integral of 1 over x dx? ln absolute x, very good. Computed from 1 to e, which gives me 1 over e minus 1. And now I have ln e minus ln 1. ln 1 is 0. ln e is 1. So answer is 1 over e minus 1. Now you can use your calculator and figure out what that value is. Has to be 0 point something. I'm getting to the calculator, just want to compute this so that I can give you a problem to work on. And then office hours. So you have the exact value and you have approximated value. What have I done here? I took 1 over b minus a, this is your interval a and b, 1 over b minus a to b, function dx, integral of 1 over x. The antiderivative is ln x, f of b minus f of a, times the term in front, and compute it. All right, so one of these for you to enjoy, and we're done. This looks sufficiently disgusting. F of x equals to x 1 minus x on 0 to 1. Okay, so I hope you integrated this in a proper way, which is distribute and then integrate each one rather than, all right, because you cannot integrate products. So the average is 1 over 1 minus 0, integral 0 to 1. You distribute this as x minus x squared dx, which is 1 over 1 is 1, so I don't have to write anything. Integral of this is x squared over x minus over 2 minus x cubed over 3 from 0 to 1. So it's 1/2 minus 1/3, 1 over 6. I'll see you either for office hours or next Saturday.